connected up to a circuit that looks like this. Question, what is the current provided by the battery in that circuit? Talk to your neighbors about this. Do a calculation. And I'm going to call someone's name out of the box to tell us what you get for the current in this circuit. What do you got?
Well, I've gotten that the resistance, at least of the first, you can figure out the resistance of the first two is R over 2, so it's 5.
So you're saying if I take, what you're doing is you're taking the circuit as a whole and you're reducing it to figure out its equivalent resistance. Okay, so you took those two 10-ohm resistors and they turn into 5 ohms, right? Right. Oh, and that 5 ohms is connected? To the 5 ohm, which is 10 ohms. So it's 10 ohms total for the whole circuit. Yeah. So we could take the circuit as a whole and replace it by this. 10 volts with a single resistor, the value 10 ohms. And the question is, what's the current in that circuit? And what is the potential difference across that 10 ohm resistor? 10 volts.
So it'd be 10 over 10 is 1. So
1 amp, 1.0 amps. Excellent. Because the potential difference across that total resistance of the circuit is just 10 volts. 10 volts, 10 ohms, 1.0 amps. Let's take it another step, shall we? Okay, now take a look at this. Same question, except now we're asking what's the current in each one of those resistors? Oh, and here's what we do. Rachel took the circuit and broke it down, okay, and came up with a single resistance. Now, we're not content with breaking it down. We're going to build it back up again. Oh, yes. And so let's redraw the circuit in its entirety and say what we can say about it. So it looks like this. There's a 10 ohm resistor here. There's a 10 ohm resistor here. And there's a 5 ohm resistor down here. Okay? How much current comes out of the battery? We just solved for that, right? Rachel told us how much comes out of the battery? 1 amp. So there's 1 amp that comes out of the battery here. Now I'm going to label some potentials, too. Let's call the potential at this point in the circuit 0 volts. What's the potential right here? That's 10 volts, right? Because I have a 10-volt battery, so that's a 10-volt potential. What's the potential at this point right here? Oh, I can solve that. Because tell me, how much current is going through that 5 ohm resistor? 1 amp. There's 1 amp that goes out of the battery. How much comes back into the battery? 1 amp. 1 amp. The potential is 0 down there, but the current still flows. It's still 1 amp right here. Oh, so there's 1 amp through a 5 ohm resistor, and I can calculate a potential difference as delta V is equal to I times R. That's another rearrangement of our classic equation. Current, 1 amp. Resistance, 5 ohms. What's the potential difference? 5 volts. So what's the potential at this point? 5 volts. Oh, yeah. What's the potential right here? 10 volts. What's the potential right here? 10 volts. Okay, let's look at this 10 ohm resistor right here. What's the potential difference across it? 5 volts. And so I can calculate the current in it this way. I is equal to delta V divided by R. Another rearrangement of our classic equation. Delta V, 5 volts. Resistance, 10 ohms. What's the current? 0.5. Sounds like 0.5 amps here. How about this resistor right here? 10 ohms. What's the potential difference across it? 10 volts here, 5 volts here. Potential difference across it? 5 volts. What's the current? Half an amp, 0.5 amps. Now let's just ask ourselves if this makes sense. I have a 1 amp of current coming, and it hits 2 resistors that are connected in parallel. We know when the current gets to this point in the circuit, it's going to split, right? 2 resistors that are equal, how would you expect the current to split? Equally? So you'd expect half an amp, half an amp. In fact, that's what we calculated. But the calculation that we did was totally general. You wouldn't have to do it that way. You could take that calculation and you could generalize it to any circuit. All right. Now let's look at this. And this comes back to a point that we've been talking about. It's a usage question, okay? When you're talking about voltage, I don't want you to say voltage flows, and I don't want you to say voltage is consumed. Here's what's consumed: energy. Here's what flows: current. Current's the flow of charge, okay? Voltage doesn't flow. Voltage is, its potential is like how high is the hill, okay? So if I have a battery here, I have a 3-volt battery. If I call this 0 volts here, what's the potential at this point? 3 volts. And what I've done is I've basically established a hill, okay? So there's a hill, and here's one way to get down the hill, and here's another way to get down the hill. And it's 3 volts up here, and it's 0 volts down here. And so the voltage doesn't flow. What I've done is I've established a potential difference between here and here, and I've connected resistors. But resistors will pass currents. So if I've connected 2 things which can pass current between 2 places where the potential is different, I have a potential difference across the conductor, and what happens? Current flows, okay? So the voltage just is. It just exists at spots in a circuit, and then it causes a flow of current. And what will happen is the potentials will adjust themselves. But I have a current goes through this branch of the circuit, current goes to this branch of the circuit. But now I want to ask this question. How about these 2 points right here, point A and point B? Which one of those is at a higher potential? Talk to your neighbors about that. And I'm going to ask you to weigh in on that subject, and then we're going to calculate this. What is the actual difference, VAB, between these 2 points? But which is higher, A or B? Talk to your neighbors about it. I'm going to call a name out of the box to tell us which one and why. Kayla, what do you think? Which is higher? B. You're right. How come? Yes, you're right. You're exactly right. And let's go ahead and flesh that out a bit more. This branch of the circuit right here, 2 ohms and 1 ohm. What's the total resistance of that branch of the circuit? 3 ohms, because I add them. Okay, 3 ohms connected to 3 volts. How much current goes through this branch of the circuit? 1 amp. Now I got a 1 amp current going through a 2 ohm resistor. What's the voltage drop across it? 1 amp, 2 ohms. Delta V is equal to I times R, 2 volts. So it's 3 volts here, drops by 2, and so it's down to 1 volt, and it's 1 volt here. Oh, yeah. But over here, I have 1 ohms and 2 ohms connected here, right? How much is the total resistance of that branch of the circuit? 3 ohms. How much current flows to this branch of the circuit? How much is the voltage drop across the 1 ohm resistor? And it's a smaller drop because it's a smaller resistance. So here it drops from 3, it drops by 2 down to 1. Here it's at 3, and it drops by 1 volt, and so it's at 2. So this point here is sitting at 2 volts. This point is sitting at 1 volt. And then there's 2 volts across a 2 ohm resistor. Oh yeah, just right. So what's the potential difference between point A and point B in the circuit? 1 volt. It's just the difference between 2 volts and 1 volt. Go back and think about that one again. That circuit right there kind of encapsulates everything I would hope you would ever learn about circuits. Well, resistance circuits. Capacitors are a whole other thing. But if you understand that, you're in good shape as far as resistance circuits.